the settings correctly for this live session, and let me see if I am audible to you. So in this session, in this live session, I will take your questions on this YouTube channel, that is Math Econ Lab, and I will also solve the numericals on mathematical economics. Okay, so let me see if anyone join us in this chat. Okay, let me take the first question. The question is, and if I put it here, so the question tells us, I know it is getting blurry at times, so bear with me. The question is, a monopolist produces two goods, X and Y. The demand function for each good is given us as price of good X is equal to 36 minus 3X, where Px is the price of good X, and Py, which is another demand function, which is equal to 56 minus 4Y. X and Y are the two goods for the monopolist. We need to find out the maximum revenue that this monopolist will get. Okay, so this is our question. Okay, so the settings is not going right here, and let me log this. Okay, so the question is, we have a monopolist which faces two demand functions for two goods. So we have the demand function, that is price of good X is equal to 36 minus 3X. This is one demand function for the monopolist, and we have another demand function, that is price of Y is equal to 56 minus 4Y. We need to find out the maximum revenue that the maximum revenue that this monopolist will get. Options are being given us as 300, 304, 256, and 200. Okay, so first thing is first, what we need to do, we need to find out the revenue of the monopolist. We know that total revenue for this monopolist will be equal to the price of good X times units of good X sold plus price of good Y times the units of good Y sold. That will be the total revenue for this monopolist. Now total revenue will be equal to, now price of good X is this very demand function, that is 36 minus 3X. To this we multiply by X here, plus we have Py is 56 minus 4Y. To this we multiply by Y. That will give us the total revenue first. So total revenue for the monopolist, rather the total revenue function for the monopolist will be, so 36 times X is 36, X minus 3X into X is 3X square, plus here also 56 times Y is 56Y, minus 4 into Y square is 4Y square here. Okay, so this is the total revenue function of the monopolist. Now we need to find out the maximum revenue that this monopolist will get. So to get the maximum revenue, so to find out maximum revenue, what will we do? We will differentiate. Okay, so we will differentiate this revenue function partially with respect to X and Y. Okay, so what will we do? We will find out the marginal revenue of good X and marginal revenue of good Y. So let's find out the marginal revenue for good X, which will be equal to the change in the total revenue for the monopolist due to the change in the units of good X. That means we take the partial derivative of revenue function with respect to X. Okay, so derivative of X in the first term is 1, we are left with 36, minus derivative of X square is 2 X, so 2 into 3 is 6X, so we will get 6X, and derivative of the last two terms will be equal to 0. Okay, we are getting, so Speedy Thrill is saying, brother, listen, take a break and do a flip for chat. So I'm not able to do this here because I am naive to this setup to get live on, rather to solve the question live. So I'm not able to do the proper setup. But in the next videos, if the response remains, you know, good, so I will try to improve myself. So bear with me. So this is the marginal revenue of good eggs, which is equal to 36 minus 6x. So total revenue will be maximum when marginal revenue will be equal to 0. So we set it equal to 0. Likewise, we need to find out the marginal revenue for good y. That will be equal to the change in the total revenue for the monopolist due to the change in the units of good y. That is the partial derivative of this function with respect to y. So since no y is involved in the first two terms, its derivative will be equal to 0. The derivative of y in 56y is 1, so we are left with 56 minus derivative of y square is 2y, so 2 into 4 is 8y, and we set it also equal to 0. Okay. Speedy Thrill is saying, man, do a flip for you, got it. Okay, so let it be. I'm really sorry I cannot take the live chat here because I'm not able to do the this setup. I'm not able to use it properly. Okay, so having said that, let's continue to the question. So if this is equal to 0, that means 6x is equal to 36, which means dividing both sides by 6, we get x will be equal to 6. So monopolist will choose 6 units of good x. Likewise here we set this equal to 0, so 8y is equal to 56, which implies dividing both sides by 8. So y will be equal to 56 divided by 8, which is equal to rather here it is 8, which is equal to 7. So y is equal to 7. But we need to find out the maximum revenue. So we know that total revenue will be then equal to price of good x times units of good x. Okay. For that we need to find out the price of good x first. Okay, so let me write it here. So price of good x will be equal to 36 minus 3 times the value of x that we got here, 6. So which is equal to price of good x will be equal to 36 minus 6 3s are 18, so we get here 36. Likewise, price of good y will be equal to plug y is equal to 7 into the demand function, so we have 56 minus 4 times 7, so it will be equal to py will be equal to 56 minus 4 into 7 is 28, so 56 minus 28 is 28. Now the maximum revenue for the monopolist will be equal to, so total revenue will be equal to price of good x into units of good x. So price of good x, we calculated it as 36, so we have 36 times 36 times units of good x, which is 6, plus price of good y, which is 28, obviously we calculated it, times the units of good y, which is 7. Okay, so it becomes total revenue will be 6 6 are 36, 6 3s are 18, 19, 20, 21, so 216 plus 7 7 56, 7 2s are 14, so the 15 sada ardakunu, so it is 196. So let us add them. So 6 plus 6 is 12. Now tage okay, 7 7s are 7 8s are 56, 7 2s are 14, 15 16 17 18 19, 196 plus 6 is 6 are 36, 6 3s are 18, 19 20 21, so 6 plus 6 is 12. Now tage da tage ka zitagi 3 tage 4 412. Okay, so I'm not getting the correct answer here. I have done a mistake in calculation here. So let me see. Price of x will be 18. Okay, so how the price of good X will be 18. Who is saying this? Nabinda Pradhan. Sorry if I cannot take your name correctly. So, sorry, it is here 18. 36 minus, here it is 18. That means I have done it incorrectly here. So, thanks for rectifying me. It happens with me at times. So, total revenue will be equal to price of good X, which is 18, times units of good X, which is 6, plus price of good Y is 28, times units of good Y, we calculate it as 7. So it is equal to 6 8s are 6 7s are 42, 6 8s are 48, 6 1s are 6, 7 8 9 10. So it is 108 plus 7 into 8 is 56, 7 2s are 14, 15 16 17 18 19 rather. So let us add them. We have then 0, then we have so 304. That means the maximum revenue for thank you Nabidita Pradhan for rectifying me. So it is 304 will be the maximum revenue for the monopolist. Okay, so having said that, let us take another question. So for that, let me rub this out. Okay, so let me take another question. So we have another question. The question is, if the utility function of a consumer is being given as u is equal to x to the power alpha times y to the power 1 minus alpha, what will be the marginal rate of substitution between x and y? Options are being given. We need to find out the correct option. Okay, so we have utility function for the consumer is x to the power alpha or a here times y to the power 1 minus a. Okay, we are supposed to find out the marginal rate of substitution between good x and y. Now we know that marginal rate of substitution between good x and y is equal to the ratio of the marginal utility of good x and marginal utility of good y. Okay, so marginal utility of good x means the change in the total utility due to the change in the units of good x consumed, and marginal utility of good y means the change in the total utility due to the change in the units of good y consumed. Mathematically, it is the partial derivative of utility function with respect to good x, and marginal utility of y is the partial derivative of utility function with respect to good y. Okay, so let's find out. Du upon dx. So let's take the partial here. So using power function rule, since we are taking partials with respect to x, the exponent of x becomes coefficient. So we have a, which is the exponent, then we have x, and exponent is subtracted by 1 by power function rule. Y raised power 1 minus alpha or a will remain same because we are taking partials. That is the du upon dx. Similarly, we need to find out du upon dy. That is the derivative of this function with respect to y. So exponent of y becomes coefficient. So we have 1 minus a, x raised power alpha remains same, and exponent of y will be subtracted by 1. So we have minus 1 plus 1 gets cancelled. Then MRS, marginal rate of substitution between good x and y, will be equal to, so du upon dx, we got it is a x to the power a minus 1 times y to the power 1 minus, rather we got it minus a, rather 1 minus a, 1 minus a divided by this 1 minus a x to the power a y to the power minus a. Okay, so let us do one thing. Let us transpose this y to numerator and this x to denominator. So we will get marginal rate of substitution between x and y will be equal to, it will be equal to, so we have a divided by 1 minus a. When I transpose this y here, the exponent will change. If it is minus a, it becomes plus a and it gets multiplied with this y. So we have y raised power 1 minus a times y raised power plus a. Likewise, when I transpose this x here, so it gets multiplied with this x to the power a, but exponent sign will change. So we have x to the power, if it is here a minus 1, it becomes minus a plus 1. Okay, so MRS between x and y will be equal to a divided by 1 minus a. So here we have same basis, we can add the exponents. So we have 1 minus a plus a, so this gets cancelled, we are left with y in the numerator, and likewise bases are same, we can add the exponents. So here we have a minus a plus 1, a and a gets cancelled, so we have the exponent is 1 of x. So this will be the marginal rate of substitution between good x and y. So the correct option should be ay times, sorry, ay divided by 1 minus a times x. Okay, so this B option should be correct. Okay, so let's take another question now. I hope I am audible to you. So can you, can you intimate me whether I am audible to you or not? Okay. Scholars of biology. Okay, Tahir Saab is live this time. So good to see you on this channel, Tahir Saab. It is very great to see you on this channel. So let us take the next question we have. Given the demand function, that is quantity demanded, is a function which is equal to 25 minus 4p plus p square. Q is the where p and q are price and quantity respectively. What is the price elasticity of demand when price of commodity is $5? We are supposed to find out. Okay, scholars of biology is saying, how are you, sir? You don't need to tell me as sir. I'm just a student of economics. I'm not any expert on mathematical or rather on economics, but I, as a student, I try to make myself more useful for the community as a whole. So we have a demand function, that is Q is equal to 25 minus 4p plus p square. This is our demand function. We need to find out the price elasticity of demand when price of the commodity is 5. P is equal to $5. Okay. Now let us first find out the quantity. So quantity demanded when price is equal to 5. So we have Q will be equal to, plug 5 in this equation. So we have 25 minus 4 times P, which is 5, plus P square means 5 square. So quantity demanded will be equal to 25 minus 5 for the 20. Then we have 25. So it becomes 25 by 25 is 50 minus 20 is 30. So we get quantity demanded will be equal to 30. Okay. Having said that, what is elasticity of demand? We know that price elasticity of demand is simply the change in the quantity demanded due to the change in the price into price divided by quantity demanded at that very price. Okay. Scholars of biology saying, proud of our Kashmir Hilal, sir. So it is your magnanimous, heart that is saying so. Otherwise, I'm just a student of economics, nothing more. So that means elasticity will be equal to dq upon dp, means the derivative of the demand function with respect to p which is price here. So derivative of a constant is 0, we know it. Derivative of p will be 1 here, so we are left with minus 4 plus derivative of p square is 2p. Okay, if you are wondering how, so p square is equal to exponent becomes coefficient and exponent is subtracted by 1, so it becomes 2p. Okay, like if we have x to the power n, its derivative with respect to x is n becomes coefficient and exponent is n is subtracted by 1. Okay, simple thing, no rocket science. Now elasticity of demand will be equal to dq upon dp is minus 4 plus 2p into price is being given us as 5 and quantity demanded at that very price we calculated it as 30. Okay, so I should have plugged the value of p here also, so which is 5. Solving it, we will get minus 4 plus 2 ones are 2 15s are, then we have 5 ones are 5 3s are. Sorry, my bad, I have done it incorrectly here. Okay, so let me rectify myself. So elasticity will be equal to minus 4 plus 2 times the value of p is 5 times p, which is 5, divided by quantity demanded, which is 30. Okay, so minus 4 plus 10 is, elasticity will be equal to minus 4 plus 10, which is 6 into 5 divided by 30. So here we have 6 ones are 6 5s are, so 5 to 5 dafa, so elasticity of demand will be equal to 1. Okay, but the options are 5, positive 1, negative 1, negative 1.5 and negative positive 1.5 and negative 1.5. Since we know that price elasticity of demand for a normal good is always negative. Okay, since we are being given both the positive value, that is 1, and negative 1, we need to take the negative 1 here. Okay, because elasticity, the relationship between price and quantity demanded in normal situations is negative, so we will not take the absolute value, so we need to in the elasticity formula we need to have the minus sign. Otherwise we take elasticity in absolute form, but that does not make sense. But we assume that when we get elasticity as 3, we assume it is negative 3. So by this, elasticity is equal to minus 1. In this case, it simply tells us if price increases by 1%, quantity demanded will decrease by 1%. There is one-to-one relationship, rather inverse relationship between price and quantity. Dor Zafar is saying, Sahi hai bhai. Thank you, Dor Zafar. I am not able to take the questions because I am busy with solving the questions, so I have to use this time judiciously. Okay, so we are done with this question also. Okay, so this question gaya tel lene. Now let's take another question. Now let us take the question regarding solo model. Okay, the question is in solo model, if production function is y is equal to under root k times L and S, which is savings rate, is equal to 0.3, depreciation of capital is equal to 0.1, then find out y, which is small y here, steady state output per worker. Options are 9, 3, under root 3 and 0.3. Okay, so we have the solo model. For this we have the production function, that is y is equal to under root KL. We have under root KL. Can we rewrite it like this? K times L raised power 1 upon 2. So it will become K raised power 1 upon 2 times L raised power 1 upon 2. Okay, so or let us write it in this fashion. Okay, so we can write here k l raised power 1 upon 2. We are also being given the savings rate, which is small s, is equal to 0.3 in the economy. Depreciation of capital is 0.1. We are supposed to find out the small y, which is steady state output per worker. Okay. So we change this production function in intensive form. That in intensive form rather, that is in per worker form. So dividing both sides by L, what we do? So we will get small y is equal to K upon L, capital K upon capital L times L upon L. So L and L gets cancelled here. So we have y is equal to K upon L raised power 1 upon 2. So can we write it like this? Y is equal to small k raised power 1 upon 2. Okay. So we just changed it into the intensive form, per worker form. What we do, that means output per worker is equal to capital labor ratio raised power 1 upon 2. Now to find out the steady state output per worker, we need to find out the steady state condition. So steady state condition requires that if I draw the graph here, a simple graph, we have the capital per worker on the horizontal axis and output per worker on the vertical axis. Since we have this production function, let us draw it. So it will look like this. So this is our small y. We are being told that savings is 0.3. Okay. Depreciation of capital is 0.5. At steady state, what happens? We have the relation that is S small times y minus del k is equal to 0. That means at steady state, capital accumulation is equal to 0. Okay. So S is the savings rate, which is being given as 0.3. 0.3 y is equal to k raised power 1 upon 2 minus del is 0.1 times k is equal to 0. So in the steady state, what happens? Whatever is invested is used to maintain the capital stock. Okay, so there is no addition to the capital. So can we rewrite it? 0.3 k to the power 1 upon 2 is equal to 0.1 times k. Okay, dividing both sides by k, so we will get 0.3 k to the power 1 upon 2 divided by k is equal to 0.1 k divided by k. K gets cancelled, so we are left with transpose this here. So we will get, so here we have k raised power 1 upon 2, transpose it here, it gets subtracted, or rather it gets multiplied, but exponent sign changes. So here we have 1 upon 2 times 0.3 is equal to 0.1. So we get 0.3 k raised power 1 upon 2 minus 1 is minus 1 upon 2 is equal to 0.1, or k raised power minus 1 upon 2 is equal to 0.1 divided by 0.3, which is equal to 1 upon 3. That means we get, so this can be written as 1 divided by k raised power 1 upon 2 is equal to 1 upon 3. Reciprocate both sides, so we get k raised power 1 upon 2 is equal to 3, or k will be equal to, transpose this 1 upon 2, it gets it becomes exponent but in reciprocal manner. So we will get 3 square which is equal to 9. That means capital per worker will be equal to 9. So we have this SF. I have explained all this stuff. So this is SY, that is the savings rate. Depreciation is, this is our depreciation del K here. Okay, so at steady state what happens, whatever since savings is equal to investment in this case, so whatever whatever investment it is, rather whatever investment is made, it is used to maintain the capital stock. So there is no addition to the capital, so it is here 9. So we got capital per worker is equal to 9, but we are supposed to find out the output per worker. So let us find out. Plug K is equal to 9 into this equation. So we have Y is equal to 9 raised power 1 upon 2, which is equal to 3 square raised power 1 upon 2. So this gets cancelled, or Y will be equal to 3. That means output per worker will be equal to 3 in this case. Okay, I know I have not done justice to explain all the stuff, what is meant by the steady state, or how do we arrive at this very equation, but I have explained it in my other videos. Okay, so if you bear with me, I will take another question. Eco Pandit is saying, sir, can you solve steady state previous year's question? So I'm just, yes, I will take those very questions, but I have the time constraint. Whatever I can do, I throw it on the YouTube. Okay, now we have another question. Let me take another question. The question is, if the cost and demand functions of the firm are given respectively as C is equal to 1064 plus 5x plus x square upon 25, and demand function is P is equal to 157 minus 3x, find the sale of output at which profit would be maximum. Okay, so this is the profit maximizing question. Okay, so let me see if the setup is correct. Okay, I'm not able to change the orientation here, so let us take it as it is. So we have the cost function for the firm is being given us as C is equal to 1064 plus 5x plus x square divided by 25. Okay, also we have the demand function, that is P is equal to 157 minus 3x. We have to find out the sale of output. By sale of output, we mean the price of output at which profit would be maximum. Okay, so we know that profit would be maximum. So EcoPundit is saying, sir, please bring videos on econometrics also. It's humble request, since I have been watching your channel since 2 years. I would have taken the econometrics videos also, but my setup is very limited. In econometrics, we have a colossal amount of data. Then we can explain the things, and it is very I will not say impossible, it is very difficult to do the econometrics session on this whiteboard. For that, I don't know how can I take the econometrics, but in econometrics I can take the basics only, like population regression function, sample regression function, autocorrelation, heterodicity. Up to this I can take, but I have the constraints, so you have to bear with whatever I can make. Okay, I'm really sorry, I cannot take that very thing. So nonetheless, we have this cost function, this demand function. We need to find out the price at which profit would be maximum. Options are 157, 3, 25, and 4. Okay, so let me see if anyone or any of you can answer this question, then I will solve it. Okay, so I'm waiting for your response. Can you do? Okay, this is the question. We have the cost function here. So this is the cost function, this is the demand function. You are being told to find out the profit maximizing uh, price, okay, or the sale of output at which profit would be maximum. Okay, so Ecopundit is saying price is equal to marginal cost. So price is in fact equal to the marginal cost. Okay, but how do we take, what will be the numerical value of the price here? So can anyone guess? Okay, we have the options 157, 3, 25, and 4. Okay, among these you have to pick up the right option. Okay, it's the basics question, basic question. Okay, let me wait if anyone can solve it. So Ecopundit is saying price is equal to marginal cost. If P is equal to marginal cost, so let us see if P is equal to marginal cost, or we can equate the marginal revenue with marginal cost. Okay, so we have this cost function and this demand function. You are being told there to find out the profit maximizing price. Okay, so let me see. So if any new person is joining this live session, please subscribe this channel. Okay, that is the only motivation for me to make more useful videos for you. Okay, so I am just waiting for your numerical answer to this question. Okay, now let me solve this question. For that I need to rub this out. So we know that for profit maximization, what we do, we equate the marginal revenue with the marginal cost. Okay, this condition must hold for profit maximization. Ecopen is saying, are you working somewhere as a teacher? Yes, I am working as a teacher, but I am not teaching the economics there. So let us first find out the marginal. To find out the marginal revenue, first we need to find out the total revenue. Total revenue, as you know, it is price into quantity. So price function is being given us as, rather the demand function is 157 minus 3x. To this we multiply by x. So total revenue will be equal to 157 x minus 3x square. Okay, this is the total revenue. And then what will be the marginal revenue? Marginal revenue will be the change in the, rather we need to take the derivative here, the change in the total revenue due to the change in the output. Okay, so can you take the derivative here? So are you working somewhere as a teacher? I don't teach economics there. So let's take the derivative. Derivative of x is 1, so we are left with 157 minus derivative of x square is 2x, so 2 into 3 is 6x. This is our marginal revenue. Now we also need to find out the marginal cost. So marginal cost, as you know, marginal cost is simply the change in the cost due to the change in the output. So cost function is derivative of a constant is 0, derivative of x is 1, so we are left with 5 plus derivative of x is 2x, then we have 25 here. This is our marginal cost. Now we equate marginal revenue with marginal cost. So we have 157 minus 6x is equal to 5 plus 2x divided by 25. Okay, transpose this 5 here, this 6x here. So we get 157 minus 5, it is 152 is equal to, so we have 2x upon 25 plus 6x. Solving further, we get 152 is equal to do the cross multiplication here, so we have 2x plus 6 5s are 30, 6 2s are 12, 13 14 15, so 150x divided by 25. So we get 152 is equal to 150x plus 2x is 152x divided by 25. So cancelling 125 on both sides, we get x will be equal to 25 in this case. So profit maximizing output will be equal to 25 in this question. So the correct option should be C option. Okay. So let's take another question. So we have another question which is related to the Harrod-Domer model. The question is, in an economy, if marginal propensity to save is 12%, productivity of capital is 25%, and income is equal to 150 billion, then based on Harrod-Domer model, to maintain full employment, at what rate income must grow? The question is, we have marginal propensity to save is equal to 12%. Okay. Productivity of capital is 25%. Okay. And income is being given us is 150 billion. We need to find out the rate of growth of income here. Okay. So it is very simple. So growth rate of income will be equal to savings upon incremental capital output ratio, so ICOR. Now here we are being told that the productivity of capital is 25. Okay, so what is the capital output ratio? Incremental capital output ratio, it shows us how many units of capital are used to produce 1 unit of good output rather. Okay, ICOR, savings rate, and the basic assumption of the Harrod-Domer model is that savings is equal to investment. So growth rate of output is simply the ratio of the savings and incremental capital output ratio in this case. So since savings is being given us as marginal propensity to save means the savings function here, which is here 12% divided by productivity of capital means incremental capital output ratio. Okay, higher the capital output ratio, lower the productivity of capital. Okay, if capital output ratio is high, if ICOR is high, it means productivity of capital is low. Why? Because high, if we have a capital output ratio, let us say 4, it means we need 4 units of capital to produce 1 unit of output. And if we have the capital output ratio, let us say 2, it simply means we only need 2 units of capital to produce 1 unit of output. That means this will be more productive. 2 is more productive than 4, if we talk about the incremental capital output ratio. Okay, having said that, so we have 12% divided by 25% here, so we will get here, so we have 12 divided by 25, which is equal to, okay, so it should be equal to 12 divided by 25. Let us see. So we have 12 here, we have 25 here, here we have point, here we have 0, 25. Okay, savings divided by productivity of capital is 25%. 25%. Why I am not able to get it correctly? Okay, so since it is in 12% upon 25%, so can we write 12% as 0.12, or let's write here 12% divided by 25%, which is equal to 0.12 divided by 25% can be written as 0.25, so which is equal to 12 divided by 100 divided by 25 upon 100, which is equal to 12 divided by 100 into 100 upon 25, so this gets cancelled, into 100%, so we have 12 divided by 25, 12 divided by 25. Okay, so we have here 12, we have 25 here, so 0.0, so it becomes 25. I'm not able to solve it here. Okay, so I don't remember correctly how to solve this question. Okay, so let us I will solve it in next session or in any other video. Okay, so marginal propensity to save is 12%, productivity of capital is 25%, that is being given us here. To maintain full employment, okay, can any one answer here the correct option? I'm not able to comprehend the question. I have taken the questions at random, I have not solved them earlier. Productivity of capital is 25%, so that is 12 divided by 25. Okay, I am waiting if any of you can give the correct answer to this question. Income is being given us as 150 billion, but I don't think we have to do anything with the income in this question. So we have 12 divided by 25. 25 minus 12, that is not correct. Okay, savings divided by income. It is savings divided by income. So income is 150 billion, savings out of income. Okay, so that can be savings out of income means, so we have 12% of 150 first. Okay, savings out of income divided by capital output ratio. Okay, so capital output ratio savings divided by income, that will not help any. Savings is actually, savings is a proportion of income. That is true, but in this case we are being told that marginal propensity to save is equal to 12%, which can be written as 0.12. Productivity of capital is 25%. Okay, so productivity of capital, if it is 25% and income is 150 billion, savings out of income divided by capital output ratio. Okay, if it is 25, इंक्रीमेंटल कैपिटल आउटपुट रेशियो शायद आपको निकालना हो. नो, वी हैव टू फाइंड आउट द rate of income, growth rate of income here. Option seems pretty correct. Question is also correct, but I am not able to. Modern propensity to save, it's yeah, this is correct. Productivity of capital is 25%, and if income is being given us, how do we calculate the productivity of capital? 25%. So Econ is saying capital output ratio. So capital output ratio, productivity of capital means capital output ratio. That is correct, but why I am not getting the correct answer according to the options? So savings upon incremental capital output ratio. Okay, there seems some mistake in calculation. Savings upon capital output ratio, productivity of capital is this 0.25. Okay, I am not able to solve it, so let us take it to another session. 25, Ecopendis is saying 25 multiple by 100. So if we 25%, if we multiply it by 100, so it will become 25, rather multiplied by 150. So it is 25 upon 100 into 150. So 5 2s are 5 3s are 25 into 3 is 75 upon 2. Okay, so 75 upon 2 is our capital output ratio, if this seems correct. Then savings out of income is 12%. 12% of 150, so it will be equal to 12 divided by 100 into 150. So 2 5 2s are 5 3s are, so it is here 36. Then we have divided by 75 divided by 2, so we have 36 divided by 1 into 2 divided by 75, so it becomes 72 divided by 75. Okay, okay, so I guess there is some mistake, not in question but in the approach I am solving it. Oh, okay, so let's take it into another session, or I will solve it offline. Okay, so that's it. So thank you, Eco Pandit, for remaining in this session. So I guess I have done all the questions. So we have taken all the questions. I don't remember any other question. If you have any question in mind regarding mathematical economics, so I am here to solve those questions. Okay, I cannot remember any question this time. Eco Pandit is saying good night, sir. Good night. Keep shining and stay blessed. Do you take live session daily? No, I do not take live session daily. This was an experimentation video, whether I can take the live session or not. Okay, so let me see you in next video, and let me see if I can do any other question. I am just trying to see if I have any question here. I cannot find out any question here. Okay, but I am still here. Okay, we have another question. Let me take that very question. Suppose we have the utility function for the consumer, which is equal to x times y. Okay, a consumer is facing this kind of utility. Okay, so let us suppose price of good x is $1, price of good y is $2, and income of the consumer is, let us suppose, $12. We need to find out the optimal consumption bundle. Optimal consumption bundle that maximizes utility of the consumer. Okay, so the question, the solution will be to maximize the utility derived from the consumption of good x and y, which is equal to x times y. This is the utility function subject to the constraint that the consumer is facing, that is price of good x times units of good x plus price of good y times units of good y should be equal to total income of the consumer. Okay, so Ecopandit is saying Lagrangian method. Okay, so we can solve it using Lagrangian method also. Using tangency condition, we can also solve it. So specifically, our budget constraint is price of good x is $1. So we have 1 into x, which is equal to x, plus price of good y is 2. So we have 2 times y is equal to income, which is 12. So we want to maximize the utility of the consumer subject to the constraint that he is facing. Okay, so if we take the graph, simple graph here, so we have good x on the horizontal axis, good y on the vertical axis. So with the given budget line, rather with the given budget, sorry, let me do the color combination correctly. We have this budget line. With the given budget, consumers endeavors to maximize his satisfaction, his utility. So this is the indifference curve which shows different combinations of units of good x and y that give same level of utility. So let us say this is IC1. So here there is the improvement in attaining higher utility. Let us take another indifference curve, which is IC2. So if we solve it using tangency condition, that means to find out the optimal consumption bundle, consumer will equate the marginal rate of substitution between good x and y with the ratio of the prices, price of x upon price of y. Okay, so MRS is simply the marginal utility of good x upon marginal utility of good y. It should be equal to the price of x and price of good y. So we have 1 upon 2. MUX means the partial derivative of utility function with respect to x. MUY means the partial derivative of utility function with respect to good y. Okay, should be equal to 1 upon 2. So taking partial derivative with respect to x of the utility function, derivative of x is 1, so we are left with y. Derivative with respect to y of this utility function is, so derivative of y is 1, we are left with x should be equal to 1 upon 2, or y rather 2y is equal to x. Now we plug this value of x is equal to 2y into the budget constraint here. So since x is equal to 2y, so we have 2y plus 2y is equal to 12, which gives us 4y is equal to 12, or y is equal to 12 upon 4, which is equal to 3. That means consumer will choose 3 units of good y, and how many units of good x? Plug x is equal to 2y, so x will be equal to 2 into 3, which is equal to 6. Okay, so the optimal consumption will be to choose 6 units of good x and 3 units of good y. Okay, I hope I make myself clear in this video. If there are doubts regarding this session, you can you can contact me on Telegram channel, where I will take your doubts if I have the time constraint available. Okay, so it's getting too late this time, so let me end this live session. So hope all you are fine, and especially Eco Pandit, keep shining and stay blessed. Thank you.